Lecture, we will talk about rational exponents and radicals. Let's review those two columns we have learned before. The first one says that 1 squared is 1, 2 squared, 2 times 2 is 4, 3 squared, 3 times 3 is 9, 11 squared, 11 times 11, which is 121. 12 squared is 12 times 12, which is 144. Here is that you have a given number, you square it, you have the second column. If you want to go back from the numbers in the second column to find out the first column, the numbers in the first column, you can do in two ways. You see, the one way is to use the radical sign. Radical 4, from 4 to find out 2. Another way is to write 2 to the 1/2 is 2. Because 2 squared is 4. So if you put 1/2 on the shoulder of 4, that's another way to find 2. This way, on this column, is called radical expression, radicals. And this column, you see on the shoulder, there are numbers. And this number right here, 1/2 is a rational number. So this expression with rational exponents, 1/2 is a rational number. So if you want to go back from the right-hand side to find out left-hand side, you can either do by radical expression. You see radicals on 36, you then have a 6. Here is 2, so you put 1/2 on the shoulder of 36, you will go back to find out 6. Okay, so 36 to the 1/2 is 6. So there are two ways to find out the original number, such that the original number squared is the radicand right here. Okay, look. This is about cubed. 1 cubed is 1. 2 cubed is 2 times 2 times 2, so you have 8. 3 cubed is 6 cubed is 6 times 6 times 6. 6 times 6 is 36. And then times 1 more 6 is 216. So again, if you want to go back from the numbers on the right-hand side to find out original numbers, there are two ways. One way is by using radical sign. You see radical sign with 3, because here is 3, so you put 3. Right here, you have this one to this one. You put 3 on the radical sign for 8, so you go back to find out 2. And here you want to write cube root of 216 from this number to find out 6. So you want to write in this way. And also you can put 1/3 on the shoulder of 216 on this number, so you go back to find out 6. If you want to put like 1/3 on the shoulder of 8, you can write in this way from 8 to find out 2. Okay? And 1 is special. You can see you put 1/3 on the shoulder of 1, you have a 1. You put 1/2 on the shoulder of 1, you still have a 1. You put integer on the shoulder of 1, you have a 1. You put integer 3 on the shoulder of 1, you have a 1. So 1 is special. Alright. So basically, those two columns and those two columns tells us that the radical expression nth root of a equals a to the 1 over n. The right-hand side 1 over n with rational exponent. Left-hand side a is called radicand. This sign is called radical sign. And this n is index. You can see here we used index 3. If index is 2, we don't write. If index is 4, we need to write. Index can be 5. Okay? Can be 6, 7, whatever. Now, let's look at a couple of notes right here. Note 1 says that negative 1/2 squared is 144. It is because negative 12 squared is 144. So negative 12 squared means negative 12 times negative 12. So you have two negatives. That's positive. 144. So it is possible that when you go back from 144 with the radical sign, then the value could be negative 1, could be negative 12. So in order to avoid confusion, you see radical 144 is positive 12, but it is possible negative 144 can choose negative value. Mathematically, remember, we define radical 144 is positive. We forget about negative. We don't say radical 144 is negative 12. We say that's positive. And then how to get the negative? If we put negative sign on both sides, then we have a negative radical 144 is negative 12. So we do it this way. We don't write radical 144 is negative 12. Okay, that's one note. Another note is that any number squared is positive. You see, negative 12 squared is negative 12 times negative 12 is 144, positive. And negative 3 squared is negative 3 times negative 3, two negatives, we get positive 9. So if you go back, you can see it doesn't matter, it is positive number 12 squared or negative number 12 squared, you always get a positive. Then, if you want to go back from positive, it could be negative or positive. But you can never find out negative some number, go back to find out original two numbers. This is because, again, positive or negative numbers squared, you always get positive. So there is no way you can go back, find a number, from negative 9 go back to find a number, such that that number squared is negative 9. So we say negative 2, choose radical sign, negative 9, choose the radical sign, or radical negative 100 are undefined. This is because there are no numbers squared, you get negative 100. No number squared, you get negative 9. And no number squared, you get negative 2. Okay, in the real number range. Because positive, negative, you always get positive. So you cannot find a negative number to go back to. Okay, so that's one thing. Another thing is that note 3, negative 1 cubed is negative 1. This means what? Negative 1 times negative 1 times negative 1 because it's cubed. 3 negatives, you get negative 1. Then, from negative 1 go back to negative 1 is cube root of negative 1 is 1 then. Negative 2 cubed is negative 2 times negative 2 times negative 2. 3 negatives, so we get negative 8. And then when you go back from negative 8, choose the cube root, you have a negative 2. From negative 8, you get negative 2. And then here is from negative 27, you go back to find out negative 3. You see right here? Cube root of negative 27, go back to find out negative 3. Because negative 3 cubed means negative 3 times negative 3 times negative 3 3 times. So we have 3 negatives, so it goes negative. And then 3 times 3 is 9, and then times 1 more 3, you have a negative 27. That means it makes sense that when you go back from negative 27, choose the cube root, you have a negative 3. But again, you cannot go back from a negative number, choose the square root to find any number. Okay, that's impossible. It's because the reason right here, you can always find a positive number here. Okay, but here, cubed, it can be negative. Okay, so is the case here and here. So 3 things you want to keep in your mind. 1, 2, 3. Now, let's recall some things we learned before. We know 2 cubed is 2 times 2 times 2. And 5 cubed, 2 to the 5th is 2, 2, 2, 2, 2, 5 times. So you can see right here we have actually 8 2's. 2 to the 8th is because 3 2's plus 5 2's, we have a total 8 2's. You can find out this number, of course. Here I want to remind you is that 2 cubed times 2 to the 5th, you wanted to add 2 exponents, 3 plus 5, which is 8. Now, 2 to the 5th over 2 cubed, upstairs it has 5 2's, downstairs it has 3 2's. We know upstairs, downstairs you can cancel 2, 2, 2, 2, 2, 2. So eventually you have a 2, 2, this 2 which is 2 squared. This 2 is actually from 5 minus 3. So when you do the division, you want to do the subtraction for the exponents. When you want to do the multiplication, you want to do the addition for the exponents. If 2 cubed divided by 2 to the 5th, we know 2 cubed is 2 times 2 times 2. Of course, you can put 1 here because 1 times any number is that number. Now 2 to the 5th, downstairs there are there are 5 2's. You can cancel 3 2's upstairs with the 3 2's downstairs. So upstairs you have a 1 left over. 2 times 2 is 2 squared. So this tells us that 2 cubed divided by 2 to the 5th is 1 over 2 squared. On the other hand, since here we do the division, is exponent 3 minus 5, which is negative 2. So this tells us 2 to the negative 2 equals 1 over 2 squared. This negative sign actually tells us that if you want to delete this negative sign, you want to put 1 upstairs, and then this negative sign will disappear. That's 2 squared. Okay, so 2 squared goes to be like a denominator, and 1 always is a numerator. The fourth one is this one. This one tells us that 2 cubed, then squared. We know 2 cubed is 2 times 2 times 2. You then square it, then you have a what? This whole thing square means there are 2, 2, 2, 2, 2, 2 twice. Okay? So this tells us that the quantities inside the brackets repeat twice because there is a 2 right here. Okay? So we have a 2, 2, 2, 2, 2, 2. In total, we have 6 2's. This is actually because 2 times 3 or 3 times 2 on the exponents, we have 6. Okay? Now, those are the rules we got to remember that. Let's do some examples right here. This example is cube root of negative 1 over 64. You can do is that do the cube root separately both for numerator and denominator. Cube root of negative 1 is negative 1. We can see clearly right here just now we said cube root of negative 1 is 1. You see right here. Okay? So here cube root of negative 1 is negative 1. And cube root of 64 is 4. Cube root of 64 is 4. So right here. So the answer is negative 1/4. Try this one yourself. You see the cube root of negative 1 is negative 1, and cube root of 27 is 3. So that's actually negative 1/3. Cube root of 27 is 3. So clearly you can do like that. All right. Now, let's look at this example. This example says that 32 to the rational number 4/5. We know 4/5 is actually 1/5 times 4. Based on 1/5 times 4, you see if here is multiplication, 3 times 2, 3 times 2. So basically you do is that actually 32 to the 1/5, then to the 4th. So this one, 1/5 times 4 is like 3 times 2. This one, 32 to the 1/5, then to the 4 is like 2 cubed, then squared. Eventually 3 times 2. Okay? So they are equal. It is basically based on the rule 4 right here. Now, 32 to the 1/5 is actually from 32 go back to find out a number. such that that number to the fifth is 32. So that number, you see, we know those two are equal. That's because something right here. Okay? So they are equal. And then we know the fifth root of 32 is 2, because 2 to the fifth is 32. And then to the fourth, so you have a 16 here. Try this question yourself. This is negative 8 to the quantity 4/3. So you want to do in this case is like that. You see 5 downstairs on denominator, so you choose fifth root of 32. And then 3 downstairs should be negative 8 to the cube root. We know negative 8 to the cube root, okay, which is negative 2. Which is negative 2. Alright? And then here you have a negative 2. And then to the fourth, then you have a 16. You have 16. Okay? Now, let's look at this example. This example says that 125 to the negative 2/3. Now, this one tells us that negative exponent, if you want to delete this negative sign, you have to put 1 upstairs, and downstairs is 2 squared without negative exponent. So based on rule 3, if you want to delete this negative sign, you want to put 1 upstairs as numerator, and then 100 to the 2/3 without negative in front of it. Okay. Now, based on the things we did above, like the example right here, 3 downstairs as a denominator, so you should do is with 125 to the 1/3, and then squared. Okay? We know 125 to the 1/3 is 5. So right here, then you have 125 to the 1/3 is 5. And then you square it, which is 25. 5 squared is 5 times 5, which is 25. So it's 1/25. For this one, you want to try yourself. Okay? You want to try yourself. You have a negative sign. If you want to delete that, you want to move 27 to the 2/3 on denominator. 27 choose cube root because there is a 3 here. 27 choose cube root is 3. We have a negative 27 choose cube root is negative 3. Without negative sign here, you choose cube root, then you should have a positive 3. Okay, you see right here, 27 choose cube root is 3. It's the same thing we say 27 to the 1/3 is 3. So it says here, 27 to the 1/3 is 3, and then you square it. You have a 9. So the final answer is 1/9. You try yourself. Okay? You try yourself. Now, 2 more examples right here. This one says that simplify and write the expression with positive exponents. The first example says that x to the 1/9 times negative 4/9. Here is multiplication. Based on this rule, we should add 2 exponents. So here we add 1/9 and negative 4/9. 1/9 and negative 4/9. Denominators are the same, both are 9. We add 1 with negative 4, we have a negative 3. 3/9 can be reduced to 1/3 with negative in front of it. Again, delete this negative, we need to put 1 above it. Okay? And then downstairs we have a x to the 1/3 without negative sign. And then we have a positive exponents. Try this one yourself. That's negative 5/2 times y to the negative 3/2. You want to add those two numbers together, negative 5/2 plus negative 3/2, which is negative 8/2, which is negative 4. Negative 4, delete negative, put 1 upstairs, keep positive exponent, so that's y to the 1/4 downstairs as a denominator. Okay? Now, the last one. Last one right here is a to the 4/5 over a to the negative 3/5 equals a to the difference of two exponents is upstairs minus downstairs. When we do division, you want to do 5 minus 3. 5 minus 3. And here we do 4/5 upstairs exponent minus the downstairs this exponent minus negative 3/5. We know negative comes to be positive. So you have a 3 plus 4, which is 7, and then 5 will keep it. Try this one yourself. It says z over 2/3 divided by negative 1, z over negative 1/3. You do subtraction for exponents. That's 2/3 minus negative 1/3. That's negative comes to be positive, so it's 2/3 plus 1/3. That's 1 plus 2 as a denominator equals 3. Downstairs it has 3. So it basically the final answer is z to the first. It's just z. Okay? Alright. So please review this lecture. I will see you next time.